Hi guys, my name is Amit and welcome back to my channel Biotechnologies. So today we'll see the numerical calculation of correlation, covariance, variance and standard deviation. So guys, if you haven't been through my last video where I explained these statistical techniques, so I will highly recommend you to go back to my previous video lecture where I explained each and every things about the correlation, covariance, variance and standard deviation. What is the concept of this statistical techniques? Why we use the this statistical technique on the data set, right? So today we'll see the practical example of these statistical techniques. So let's we have the two-dimension data sets. Again, the previous example, we have a person feature data set where as a feature we have a height and weight, right? And based on these two features, let's in this data set BMI category of the person is given. So let's we have a height in inch, weight in kg, right? So let's start with the 45-inch height person having weight is 40 kg, 50 height 45 kg, 55 height 50 kg, and 60 height 55 kg, 65 height 60 kg, and so on. The category is fit. We have three different categories: fit, then slim and fatty. So in this category the person categorized as a fit person. Fit might be we have here 60-inch height and person with the the person with 95 kg, it categorized as fatty, and the height with 65 and weight is 55 is categorized as a slim, right? So we have this data sets, right? So let's see how these two variables are correlated to each other. What is the covariance of these two variables? What is the correlation between two variables? How these values are distributed on xy plane? That is, what is the uh, variance of this data set, and what is the standard deviation of these variables, right? So let's start with the covariance. So we have formula Covx comma y is equal to summation of xi minus xi bar into yi minus yi bar, where I is belongs to 1 to n divided by n minus 1. So guys, sometimes you find the this formula as a xi minus x bar into y minus y bar summation of where I belongs to 1 to n divided by n minus 1. Sometimes you see n divided by n, right? So here the concept of the population and the sample. If you deal with the whole population, we write divided by n, right? If we are dealing with the sample, it means we have the large population, and from this large population we have a sample, right? So in that case the formula would be changed. It would be summation of xi minus xi bar into y minus y bar divided by n minus 1. So let's assume that this is the sample of your local city where we collected the five five persons features where they categorize in the fit category, right? And on this five values, right, we will see whether height and weight is positively correlated or they are negative correlated, what they are distributed from the mean, and what is the standard deviation, what is the average deviation from the mean, right? Again, for variance we have a formula sigma. This variance is called sigma square with the summation of xi minus xi bar whole square divided by n minus 1, where I belongs to 1 to n, right? And the standard deviation denoted by sigma is the under root of variance. So this is sigma of I is equal to 1 to n xi minus xi bar to the whole square divided by n minus 1, right? So we can clearly see, guys, the relation is looks like the positive relation between this two variable. Let's say that height is the independent variable and uh, weight is the dependent variable. We are denoting by y, right? So at initial level, the height is 45 inch, the weight is 40 kg. While we increase the height 50, right, the weight is also increased. Here again, when we increase the height 55, the weight is increased to 50, from 45 to 50, right? And when we increase the height to 60, the weight is again increased from 55 to 60. It makes, we can, because it's very small data, right? It's only with the five uh, samples, right? So in this data set we can clearly see that there is a positive correlation, right? What's happened if this data is in million, right? Millions of record we have, then how we calculate it? It's not possible to calculate manually, but using this simple and very short data set, we can calculate the correlation, covariance, variance and standard deviation. So for me, this is positive correlated, right? So covariance will also be positive, it should be positive, right? The strength we will measure, if this height and weight are positive correlated, what is the strength of the correlation? We will measure through correlation. How the data is distributed from the mean, we measure through variance and standard deviation, right? Again, if you haven't been through my last video lecture where I explained the concept of correlation, covariance, variance and standard deviation, I will highly recommend you to go to my last video lecture where I explained this all statistical analysis of correlation, covariance, variance and standard deviation, right? So let's start. Let's calculate the covariance first, right? So uh, for now I'm going to, because this is the categorical variable, we will not touch this. This is the class level. We will see the variation, standard deviation, correlation and covariance between height and weight, right? So I'm going to drop this for now because I'm not doing the classification problem. I'm doing the analysis, statistical analysis. So let's assume this is x. Let's assume this is x. This is y. So now x minus x bar. Here we calculate. Here we calculate y minus y bar, right? Now I'm also deleting this last records because I don't want to complicate this numerical calculation, right? So for x minus, first of all, we need to find out the x bar. It means the mean of this value. So this is 45, 50, 55, 60 and 65. So basically it would be 275. Summation of x is equal to 275. You can calculate yourself. This is again 60, 60, 120, 170, 220, 260, 5, 5, 10, 15, 275. Now, the average is then x bar is equal to, two, sorry, 275 divided by the number is 1, 2, 3, 4, 5. So, 5, right? Uh, let's say that this is the population, this is not the sample, because if you calculate or getting the average or divide, I mean, if we will divide it by 5, it will be every divisible, otherwise it will throw some float values. I don't want. So let's assume it's the population, it's not a sample. If it's sample, then the denominator you have n minus 1. If it's population, so in the denominator you have only n, right? So this is the 55. So now x bar is equal to 55 we have. X minus x bar. So 45 minus 55 is equal to minus 10. 50 minus 55 is equal to minus 5. 55 minus 55 is equal to 0. 60 minus 55 is equal to 5. 65 minus 55 is equal to 10. Right? Here, y bar. For x we have calculated x minus x bar. For y we need y bar. It means here we need summation of y is equal to, calculate, 250. Here is 250. Just revise it. 250. Right. So y bar is equal to 250 divided by 5 is equal to 50. Now y minus y bar, 40 minus 50 is equal to minus 10. 45 minus 50 is equal to minus 5. 50 minus 50 is equal to 0. 55 minus 50 is equal to 5. 60 minus 50 is equal to 10. Now we have x minus x bar, y minus y bar. Right. Now we can calculate the covariance of x and y, and definitely we should get it as a positive value. Right. So covariance is equal to summation of xi minus xi bar into y minus y bar. So the multiplication of these two, right? So minus 10 into minus 10 is equal to 100, plus minus 5 into minus 5 is equal to 25, plus 0, plus 5 into 5 is equal to 25, plus 10 into 10 is equal to 100, divided by n is equal to, we have 5. We have number of rows is equal to 5, then it means n is equal to 5. So if you calculate it, 250. So 250 divided by 5 is equal to 50. So we got the value of covariance is 50. This is the positive value. See what I have told you. Looking to the data, it seems it's a positive correlated, because if increasing the value of x, y is also increasing. right? It means the positive correlation. So from covariance, we know that the covariance tells us the direction of the relationship between the variable. Now the direction is positive. It means x and y are positively correlated, right? Now let's calculate the variance. Let's see the uh, standard deviation is the under root of the variance. Both are using the same things. We just what is standard deviation? This is we wanted to see the distribution of the points from the mean, right? So let's calculate the sigma. Sigma is under root. Let's sigma is under root xi minus xi bar whole square. So xi minus xi is equal to 10. So this will be 100 plus 25 plus 0 plus 25 plus 100. The same thing. Divided by 5. So is equal to 250 divided by 5 is equal to under root 50. And the value of under root 50 would be very close to 7.1, right? So standard deviation of x is 7.1, right? The same value is given in y minus y bar as well, right? So for this value we are getting 7.1. It means for this value also we get the 7.1 value. So sigma of y is equal to 7.1. You will not find always the same value for x minus x bar and y minus y bar, right? So you can use some different data set and you can calculate using this formula and technique for getting the value of correlation, covariance, variance and standard deviation, right? Now we wanted to see the correlation. What is the correlation? And in my last video I have told you that the basic differences between correlation and covariance is correlation is standardized, covariance having their own units, where correlation is standardized and the value of correlation lies between -1 to +1. So in this case, while we calculate the correlation, it means the value should be lies between -1 to +1. So the and how we get the correlation? Using the correlation coefficient called the Pearson coefficient, denoted by the R, where R is equal to covariance of x comma y divided by sigma x into sigma y. So this is the formula for calculating the correlation value. Now we have covariance is here 50 divided by 7.1 into 7.1. Here I will I don't have the phone right now, so the value would be around let's calculate it. So it's 50.41. So now 50 divided by 50.41, that would very close to 0.98 something, right? So here we can clearly see that you can I don't know the exact float value, right? It would be around 0.97 or 0.99 as well. I don't have the calculator, so I don't want to waste my time. So but yeah, approx the value would be 0.98, right? So now we can see clearly here that or values of the correlation lies between -1 to +1, right? It's as a 0.98. So we can clearly say that height and weight are positively correlated to each other, and the strength of correlation is 98%. It means 98% positive correlated, right? So guys, this is the explanation of how we calculate the correlation, covariance, variance and standard deviation, right? So here we have the, again, let me revise this. So we have the height and weight, right? And we wanted to calculate the correlation, whether they are positively correlated or negatively correlated, or there is no correlation, I don't know. So as we earlier we already described that the data points looks like they are positively correlated, and hence in end of the calculation we found that covariance having the value 50, that this is the positive 50, it means height and weight are positively correlated, and the standard deviation of x was 7.1, standard deviation for y was uh, again 7.1, right? And the uh, correlation coefficient is equal to 0.98, that lies between -1 to +1. Right. So guys, you can also try the same calculation technique, method and formula for uh, getting the value of correlation, covariance, variance, standard deviation on different data set as well. So do practice, and if you don't, if you haven't gone through my previous video, I will highly recommend you to go to my previous video to see the explanation of these statistical techniques. Thank you so much. Please do subscribe my channel, and hit on the like button if you like this video. Thank you so much.